Hey dear kiddos, how are you? This is Varsha ma'am and I'm back with another session, Relations and Functions. Today you will be studying in depth about this topic. Let me tell you before starting, it is one of the most important chapter from class 11th. Reason being the same chapter, the same topic is continued in class 12th. The name is also same, Relations and Functions. So when you go to class 12th, ensure that you don't have to come back and watch this session next year again. So you have to pay attention to each and every statement that I'll be telling in today's class. Make proper notes along with me as we do. You know the rules, you know the conditions. If you need any changes in the session, free to comment, free to let me know, and I'll be happy to implement your suggestions. Alright. So as the name suggests, relations and functions, we will study about relations, we will study about functions. Everything is connected. I have a relation with my students, I have relation with my parents. Similarly, you have relation with your friends, your parents. Correct. Human beings have relations. So even mathematical world has relations in them. What kind of relations? Line L is parallel to line M. The relation is of parallelness. A plus B is equal to 20. The relation is, the summation gives me 20. X is greater than Y. The relation is inequality. 1 is greater, 1 is smaller. So these numbers also have relations among themselves. We are going to deal with those kind of relations, the mathematical relations. Now it's obvious. It's very obvious. For studying relations, we need at least a pair. That means two people. I alone cannot form a relation. I need someone else to make a relation, isn't it? Similarly, mathematics, the first thing when we go to study relations is ordered pairs. The first thing that you will be studying is ordered pair. Why ordered pair? Of course, we need two elements in order to make a relation. Ordered pair is a set of two elements written in parenthesis like this, where the ordering becomes important. Suppose A comma B is equal to the ordered pair x plus 2 comma y minus 3, and I say the two ordered pairs are equal. It means the first elements are equal and the second elements are equal. On solving, you will get A is equal to x plus 2 and B is equal to y minus 3. That's about ordered pairs. Ordered pair is always written in parenthesis, separated by a comma inside the parenthesis. Right? There's ordered triplet also, wherein you will have three elements inside the parenthesis. Ordered triplet. Why is ordered triplet used? You know the pairing, the relation is not restricted to only two people. It can be within three people also. So there is also a need of, yes, tripling. Ordered pair, ordered triplet. Based on this, we form something called as Cartesian product. Suppose there are two sets A and B. Suppose there are two sets A and B. When you form all the possible ordered pairs between A and B, it is called as Cartesian product. A into B, this is how we read it. Example, A set has 1, 2, B set has 3, 4, and we are interested in finding the Cartesian product. Cartesian product will be simply, you have to make pairing. Isn't it a favorite task? Isn't this is what we do in our schools and colleges? Forming pairs, all the possible pairs. 1 will pair up with 3. 1 will pair up with 4, 2 will pair up with 3, and 2 will also pair up with 4. That means all the first element with first and second, the second element with both the elements. The definition of Cartesian product is therefore, it's a set of ordered pair AB, where first element A will belong to set A and second element B will belong to set B. How many number of elements do you see in the Cartesian product? 2 and 2, total number of elements is 4. That means n of A into B is equal to n of A into n of B. You simply multiply the number of elements in each of these sets. You will get the total number of elements in Cartesian product. Ordered pair, Cartesian product. Ordered pair means two elements pairing up. Cartesian product means from two sets you take all the ordered pairs, you form all the ordered pairs. After ordered pair and Cartesian product, the next thing that we can study is relations. Here comes relations. What is relation? So relation in simple term is a subset of Cartesian product. Please remember this for a long term. Relation is a subset of Cartesian product. What is subset? Studied in sets chapter. All the ordered pairs which you wrote here, if you pick suppose 3 out of them, 4 out of them, 1 out of them, 2 out of them, or none out of them, anything that you pick up and form a set, it will be called as relation. So basically relation is subset of Cartesian product in simple words. When two elements are related by some mathematical relation, it's written as either A is related to B or A comma B belongs to relation set. A is related to B or A comma B belongs to relation set. If two elements are not related, A is not related to B or A comma B does not belong to relation set. That's how we write it. I hope you heard me. A is not related to B, A comma B does not belong to relation set. What else about relation? Suppose again there are two sets. Set A has P number of elements, set B has Q number of elements. Then how many total number of relations can you form? Total number of relations is equal to total number of subsets. And the formula for total number of subsets from the sets topic is 2 raised to PQ. Total number of relations is 2 raised to PQ. There can be variations like total number of non-empty relations, total number of empty relation. Out of all the relations, out of all the subsets possible, one of them will be empty, one of them will be universal. Do you agree with me? Out of all the subsets that you can form. Suppose these 4 elements are there in the Cartesian product. If I ask you to make possible subsets, one will be empty, one will have everything, the other will have only 1 elements, the other can have 2 elements, 3 elements, right? So various subsets can be formed, but one is definitely empty and the other is definitely universal, full. So number of empty relations 1, number of non-empty relations will be total number of relations minus 1, because 1 is empty. 1 is empty. Understood? Okay. We need to take some example to understand relations further. Here we go. Let's talk something about domain and range of a relation and also how a relation is represented in the next slide. Domain and range and codomain. A relation set is given as 1, 2, 2, 3, 3, 4. What will be the domain? Domain is nothing but it is a set of all first elements, set of first elements of ordered pair. OP is ordered pair. What is the first element of ordered pair? 1, 2 and 3. Domain can also be written as X. And range is nothing but set of second element of ordered pair in relation R. Of course, we are talking about the relation set. Domain is also, range is also written as Y. In this particular question, second element is 2, 3 and 4. That becomes the range. What about codomain? There is something called as codomain. Now to explain what is a codomain, I will represent this in a, I'll represent this in different forms. So what are the different forms to represent any relation? The first is set builder, which you saw just some time back. Set builder and roster you are already aware of. Set builder, roster. Set builder, roster meaning you separate by commas. We just saw 1, 2, 2, 3, 3, 4. Set builder means you write certain property. Suppose a comma b, a is equal to b minus 2. A belongs to set A, b belongs to set B. Some random relation I have written, no meaning as such. And the third one is arrow diagram. The third way of representing a relation is arrow diagram. This is the most simplest and sorted out of all. In an arrow diagram, you draw two oval shapes like this. Let's say this is the relation I am talking about. So draw two sets. The first set is A, the other is B. First set contains 1, 2, 3, 4 and so on. Second set, let's write 1, 2, 3, 4, 5, 6. What kind of connection can you see? 1 is connected to 2. 2 is related to 3 and 3 is related to 4. This is the arrow diagram for this particular relation which is given in arrow diagram format. The codomain here guys, the codomain. Domain is set of all inputs 1, 2, 3. Range is set of all outputs 2, 3, 4. Codomain is nothing but your set B. I mean this entire set B which has 1, 2, 3, 4, 5 and 6. That will be codomain. Range is only the elements which have been connected. Range is only the connected elements, but codomain means entire set B. Codomain is equal to set B. Please remember this, right? Next, after understanding representation of relation, we can go to inverse of a relation and binary relation. Any relation R, what will be its inverse? R inverse. And the definition of R inverse is, guys, R inverse is nothing but it is a set of ordered pair B comma A such that A comma B belongs to relation set. If A comma B is in relation set, then B comma A will be in inverse of relation. As simple as that. Your relation set is 1, 2, 2, 3, 3, 4. What will be R inverse? 2, 1, 3, 2 and 4, 3. Are you getting it? Very easy peasy lemon squeezy. What is the point that we can note from it? The point to be noted, my lord, the domain of R is equal to the range of R inverse. Can you see? The domain of R is 1, 2, 3. The range of R inverse is 1, 2, 3. I'll write it here. Check for yourself. Domain of R is equal to range of R inverse and range of R is equal to domain of R inverse. Iski topi uske sir. The range of R, what is the range of R? 2, 3, 4. Is it the domain of R inverse? 2, 3, 4? Yes. R inverse. Domain means you will check the first element, range means the second element. The domain range interchange while calculating the inverse. That's it. Binary relation. Talking about what do you mean by a binary relation. So many a times they give in question especially a relation on set A is given by A plus B equal to 2, let's say. Now they are talking about which two sets. They have mentioned only one set. So whenever they mention only one set in this format, you have to understand that they are talking about binary relation. That means a relation between two same sets. A relation between two same sets they are mentioning. They are not saying a relation from set A to set A. They just mentioned a relation on set A is given by this. Find out. So it means it's a binary relation. Okay. Fine. Anything further on relations? I guess relations from a broader perspective, if I have to summarize quickly, ordered pair. From ordered pair we get Cartesian product. From Cartesian product we get relations. When you put certain conditions between the elements of Cartesian product, you get a relation, right? Relation, what will be there in relation set? Elements which will be related. Elements which will be related will be there in relation set. Now from relation you have functions. From relations you have functions. What will be there in functions? In functions, the elements which satisfy two conditions will be present. You know, right? Relationship is very easy. But taking it to the marriage function is not that easy. You have to fulfill a lot of conditions. Similarly, in maths also, forming a relation was easy. There was no condition. But to form a function, two conditions are necessary. Two conditions are required. What is the first condition? The first condition says every input should have an output. And the second condition says every input should have one and only one output. One and only one output. Now you must be wondering, what is this input output suddenly? So far we studied domain, range, codomain. What is this input output suddenly? So guys, function behaves like a machine. Function behaves like a machine. What kind of machine? A machine in which you can give an input and get an output. Suppose the input is X, the output is Y. Juicer is a machine. Let me draw a juicer for you. Right? You put juice into it. Suppose you put this is the button. Right? There's a plug also. You put apple in it. What will you get as the output? Suppose here you are getting in a glass the juice. Suppose you are getting juice in the glass. If you are putting apple, you will get an apple juice. If you are giving the input as orange, you will get an orange juice. So input, output. Similar for function. You give an input, you will get an output. If I say my function f of x is x square, what kind of function is it? It is a squaring function. That means x, and guys, f of x is also written as y. F of x, that means output is also y. Suppose x is 1. What will be the output if you put x as 1? 1 square 1. X is minus 1. Output will be 1. X is 0. Output is 0. X is 2. 2 square 4. X is minus 2. Minus 2 square 4. Can you see you are changing the inputs and the outputs are changing depending on the input. Which means x, this x is independent. This x is called as an independent variable. Why? Because we are deciding what input we have to put. We are deciding which juice we want to have. It's on us. No restriction. But the output has a restriction. If I put apple, the machine has a restriction that it has to give me an apple juice. So output is called as a dependent variable. Guys, I'll explain those two conditions. First, understand these terminologies. Independent, dependent. X meaning the input. Y means the output. Input, output. Input can also be called as, the different name for input is pre-image, and the output can also be called as image, the different name. These are just the different names for same thing. Input can also be called as, or X can be the first element of ordered pair, Y can be the second element of ordered pair. What else? X is nothing but your domain, very important. X is the domain and Y is range. All the possible inputs are domain and all the possible outputs are range. Okay. So once you have understood the condition, the terminologies, now we can go to condition of function. My dear boys and girls, just try to think. What will you want from this machine? Simple. If I am giving one input, I should get an output. If I am giving an input, I should get an output. Do you demand from this machine? Every input should have an output. If I am giving apple, I should get apple juice. It shouldn't happen that I am giving apple and it's not giving me apple juice. Oh my god, I'll throw that juicer. We don't need such a juicer. For a function, every input should give me an output. So first condition, well verified. Second condition, every input should have one and only one output. That is also needed. That is also important. Just imagine, in this you are giving apple and you are getting apple as well as orange mixed together. Very yucks. It won't taste good. It will spoil your mood. You don't need such a juicer. You don't need such a function. You don't need such a machine. You will throw this again. So what do you want? You want that if you are giving one input, it should have one output. So every input should have one and only one output. Second condition is also valid. So the function is not demanding anything extra. It's a very nice, simple machine. What is function? Function is a machine. If anybody asks you what is function, function is a machine. Right? Like the Three Idiots movie, what is machine? Function is a machine. It performs simple operations. Now I'm going to put these two conditions in arrow diagrams and you have to answer me which of them seems correct to you. Color, which color do you want? Couple of arrow diagrams I'll make. From the arrow diagrams, try to identify which is a function and which is not a function, which can be qualified as a function and which cannot be qualified as a function. I'm drawing 5 arrow diagrams, okay? From set A to set B. Everything between two sets A and B. Between two sets A and B. Between two sets A and B. A and B. All of them have certain number of inputs and outputs. Certain number of inputs as well as outputs. Inputs, outputs. Inputs can be anything like 1, 2, 3. Output can be A, B, C, D. It's your choice. I'll leave it. I'm not naming the inputs. You just have to understand this dots means some inputs and outputs. The first diagram I'm drawing, carefully everybody will answer me in the chats. Is this a function? Is this a function? Yes or no? It is not a function. Why? Because which condition is not satisfied? The very first condition is not satisfied. Every input should have an output. Here this input doesn't have an output, so lonely. This input doesn't have that means you're giving an apple. You're not getting an apple juice. There is no machine is not working. Can this be qualified as a function, guys? Is this a function? No. Why? Because the second condition is not satisfied. Every input should have one and only one output. Here you are giving one input and getting two outputs. It's like, you know, arrow. It's like the god. You give in one arrow from the bow and multiple arrows come out. Not possible by human beings. Possible only by some superpowers. Not by human beings. You give it one and you get multiple. If you give one, you'll get one only as the output. Right. So again, this is not a function. What about this one? Is this a function? Yes, it is a function. To all those who are thinking it's not a function, it is a function. It is very much a function. Why? Both the conditions are satisfied. All the inputs have an output. And all the inputs are having only one output. So this has one output, this has one output. Two different inputs can have the same output. Right? Like for example, two different arrows can come and hit the same target. Two different arrows can come and hit the same target. But from one arrow, from one bow, can two different arrows go? No. From one bow, two arrows cannot go. But from two different bows, two arrows can come and hit a target. That's possible. Right. Or if you want to take that juicer example, if we want an apple juice, there are two options. I can put an apple or I can put some apple crush. Apple crush will also give me apple juice, apple will also give me apple juice. So different inputs can give me the same output. That's fine. Condition satisfied. Alright, next one, people. What about this? Is this a function? Yes, it is a function. If you think, ma'am, this doesn't have anything, it's fine. Who is talking about the output? Every input should have an output. And every input should have only one output. So it is very much a function. What about this? Is it a function? Yes, it is a function. Different arrows can come and hit the same target. It's absolutely okay. It's a fight. Got it, guys? Got it. Okay. Now there is a simple thing with which you can understand about whether a given thing is a function or not. That is called as vertical line test. There is something called as vertical line test. In class 12, you will learn about horizontal line test to identify whether a function is 1-to-1 or many-to-1. Here I am talking about vertical line test. Suppose the first graph is y is equal to 3. Do you know how to draw the graph of y is equal to 3? Everybody think about it, please. Pause and think. And the second graph is x is equal to 3. Think again, what will be the graph of x equal to 3? Try to plot it. So y equal to 3 meaning the line will have its y coordinate to be constant. The y coordinate will be constant. It's a line parallel to x axis. And x equal to 3 means the line will have x coordinate constant. It's a line parallel to y axis, like this, perpendicular. It's passing through this 3, 0. Here also it's perpendicular, passing through 0, 3. Right, that's your line. Y equal to 3. X equal to 3. Now vertical line test says you have to draw a vertical line. You have to draw a vertical line and see at how many points it cuts the graph. Vertical line, at how many points it cuts the graph? It cuts at only one point. It is a function. Draw a vertical line. How many points it is cutting the graph? Infinite points it is cutting the graph. It is intersecting the graph at infinite points. It is not a function. X equal to 3 is not a function, but y equal to 3 is a function, right? If you know graph of a certain function, by graph also one can identify it's a function or not, right? This few things like here and there which I say in between are OOS, out of syllabus, but to be noted, important, right? Cool. Now let's move on to the next very important portion, which is how to find domain and how to find range in relations and functions. This forms the important part. Preliminary condition is you have studied about wavy curve method. You have studied about wavy curve method. Have you? If not, I will put up a video, a basic mathematics video, let's say. You have to let me know in the comment section whether you know about wavy curve method or not. This is needed if you want to solve questions on how to find domain and range, and some basic idea of inequality like less than, greater than, less than, equal to, greater than, equal to, dot, bubble, है ना, round bracket, intervals. Interval we have already studied in sets chapter, when to use round bracket, when to use square brackets. So that basic knowledge of intervals and wavy curve is needed in order to solve questions on how to find domain. Now you'll be very happy to know that I am going to summarize all the methods on one single chart. How to find domain, you have to refer this chart every time. By referring this chart, all your questions of how to find domain will be solved. And similarly on the next page, how to find range, refer that chart. Questions on finding range will become easy for you. Right? Follow these steps. There are, let's put 4 methods to find domain. 4 methods to find domain. There can be one or two here and there, but I assume it's very simple and it doesn't hold a place in this chart. Not that crucial. The first method is when you have a linear function. The first method is when you have a linear function. The second method is when you have function in the denominator, 1 upon function. The 1 upon, or simply say you have function in denominator. You have variable in denominator. Something x is present in denominator. The third thing, when you have function inside a root. And the fourth one is combination of second and third. That means you have root of function in denominator. You have root also and function also in denominator. This can also be written like just for understanding purpose, nothing else. And this is 1 upon root of f. Just for the purpose of understanding, guys, not to be taken literally. These are like tricks to understand or solve a question. So whenever you identify a question of linear pattern, what will you say as the domain? What will be the domain in such a case? If it's specified x is the domain, remember. If it's given already that x is 1, 2, 3, that's the domain. If I'm saying if x is not given, you have a linear function y is equal to x plus 9 in the root, and they ask you what is the domain. Let's not take the root. They ask you what is the domain. It's linear. You simply go by saying domain will be equal to all real numbers. Capital R stands for real numbers here, not relation. Relation is also denoted by capital R, real number also by capital R, but in your textbook they will denote it with different ways. For relation they write with a normal color ink. For real numbers they will either make it italic, or they will lighten the ink, or they will make it bold. So if in a question there is 2R, one means real numbers, the other mean relation, there will be a difference which will be visible to you like this, and you will be able to understand which relation, which one is relation and which one is real number. Okay, so for linear function, domain is all real number. What about whenever you have x in the denominator? In any form x is present in denominator. In such a case, guys, you will consider step number 1, denominator not equal to 0. Next step, solve it. Solve it, simplify it. Simplify and find x. Simplify and find x. Third step, after simplifying you will get x not equal to some number k, where what is k? K is constant. K is some random constant. You will get x not equal to k. That means what is your domain? Domain will be all real number except this element k. Because you have removed k, x cannot be k, domain cannot be removed. That's the second method. Whenever you have anything in the denominator, for example, x plus 2 upon 9 minus x. Can you say x in the denominator? Yes. So take denominator non-zero. Then solve for x. X should not be 9. That means domain is all real numbers minus 9. Easy peasy. Got it? Yes. Right. Remove it. Whenever we have root function, whenever we have a root, the first step is the function inside a root should be equal to or greater than 0. Isn't it logical? We do not take anything inside the root to be negative, because anything inside the root is negative will make it imaginary, and we are not dealing with imaginary numbers. We are dealing with only real functions. Real functions means output should be real, input should be real. So whenever root inside the root should be greater than equal to 0, now you have to solve this by wavy curve method. This has to be solved by wavy curve method. Solve by wavy curve and find x. As soon as you will get x, guys, domain is nothing but the value of x which you will obtain from wavy curve. That will be the answer. That will be the domain, the x which you will obtain in this type of question. Here, everything is logical, nothing is coming out of the blue. Denominator should not be 0, it makes sense. We cannot keep denominator 0. And when it's a combination of 2, you will take both the things into account. That means function should not be 0 and function inside the root, right? if you have 1 upon root of function, and inside the root should not be 0, that means this should not be 0, and function should be greater than equal to 0. Solve this, you will get x not equal to k. Solve this portion, you will get x not equal to k. This is by the second method and this is by the third method. Solve it by wavy curve, you will get x. Domain will be all the x except k, right? This says domain is remove k, this say domain is x. Combine the two, domain is all x minus k. From here k is removed, from this method you will get x. That's the combination. This is the way to find the domain for any kind of question. Moving on, how to find range, guys. Let's go with 4 approaches. First, second, third, fourth. Couple of here and there which can, again as I said, can be understood. The first one is when you have discrete inputs, when the domain is discrete. What is discrete domain and what is continuous domain? Discrete means when x belongs to natural number, whole number, integers, or it is given as some set like -1, 0, 2, like it is given, the domain is given to you. What is the domain? Discretely. That's first. But second, third and fourth is when the domain is continuous. This is applicable only for continuous. That means x belongs to all real numbers. Natural number, whole number, integers, these are discrete values, but real numbers are continuous. You cannot distinguish real numbers. If I say tell me all the real numbers between 1 and 2, will you be able to say? Never. Never you will be able to say, because the values are so many infinite values between 1 and 1.1, so many values. That means it's almost continuous. So when x is real number, we say it's continuous. Second, third, fourth is for continuous, and first method is when you have discrete. Ready? So when you have a discrete input, all you have to do is substitute the input and get the output. Substitute x in f of x, and domain, range is nothing but your y. Range is same as y. Whatever f of x you will get, that is same as range. Y is f of x. Range will be equal to f of x. Got it? Perfect. So first method is simple. Substitute the x, get the y. Second method, suppose they have given you interval. Whenever you have the domain interval given to you. Suppose they say x belongs to, -2 to +2. So if they give you an interval, all you have to do is take the least value and maximum value, substitute in y and get the range. Right? Find least and maximum value of f of x by substituting interval. Range will be nothing but least and maximum value. Whatever least and maximum value you will get, that will be your range. If it's closed interval, you put close. If it's open interval, you will put open. So let's for now keep it as it is. That's the second method. The third method, it's neither discrete nor the interval is given. That means it is of the form y equal to f of x. F of x can be linear by linear, linear by quadratic, quadratic by quadratic, anything. This you are unable to understand what to do out of first and second. It's just a random question like f of x is equal to x square plus 3 upon x plus 2. Right? So you can apply, go for this third method. Some more variations are there, but yeah, for now let's go with it. The third approach says, I like to call it as an algorithm method because it's a very standard approach to find range. Range means what? Y. The approach says, simplify it in a way that x is on one side and all the y term is on other side. You have to simplify it in such a way that all the only x term is in the left side and all the y term is on the right side. Y term, constant, everything on the right, x only is in the left. After you simplify, pay attention carefully. Second step would be, once you achieve this, consider y as domain. Consider y as domain and identify type and identify the type. Consider y as domain and identify it is which type of domain. Linear, denominator, root, or mixture of denominator and root. You have to identify which type of domain it is, the y, whether y is present in denominator, whether y is present inside the root, or y is present both in denominator and root, or y is just present in the numerator. You have to identify the y, thinking it's a domain, identify the domain and solve according to domain. Solve as per domain type. Solve as per domain type. Write this, guys, it will be very helpful. Solve as per domain type, and whatever answer you will get will be the range. Whatever answer you will get on solving the domain from the previous chart, you will use the previous chart to find the value of y, and whatever y you are getting, that's range. That is the third method. And fourth method is like, it's not always applicable. Again, it is a part of your interval method. Let me write the fourth method as, whenever you have y is equal to quadratic by quadratic, linear by quadratic, right? Linear by linear. Suppose these types you have. What will you do in such types? Cross multiply and simplify. Second step, you will keep x on one side and shift everything on the other to make it quadratic in x. You will make it quadratic in x. Once it's quadratic in x, all you can say is its discriminant will be less than 0. Make it a perfect square first. Once it's quadratic, make it a perfect square. Make it a perfect square. And fourth and last approach, you use d is less than 0. That means discriminant is less than 0. B square minus 4ac less than 0. Solve. Because it's a quadratic in x, you will be getting the discriminant in terms of y. And whatever is the y becomes your range. Your discriminant will be in terms of y. Do you all agree with me? Yes or no? Will the discriminant be a variable of y? If you have a quadratic function, x equal to, something like x and y mixed, x equal to something, make it a perfect square. Its discriminant will be in y. Discriminant is less than 0. Get the answer. Solve it. Now this fourth method is like for a higher level. When you approach questions of R.D. Sharma, R.S. Agrawal, or few questions from the exemplar, or even JEE questions, mains questions, you will need this fourth method. Otherwise, the first three methods will be sufficient to solve all the questions from CBSE, particularly the NCERT. Okay, types of functions. This types of functions is again not in CBSE 11th, not in 11th CBSE, but if you are approaching competitive exams, if you are aiming class 12, then it makes a lot of sense to understand it right away, at least some basics. Same thing you will be understanding in 12th, but yeah, basics is important. You have freshly learned what is domain, what is range. Use it. When the range is equal to domain, guys, whenever the range is equal to domain, it is called as an onto function. And whenever the range is not equal to domain, it is called as an into function. Simple. Range is equal to domain, onto function. Range is not equal to domain, into function. Onto, into. Not domain, codomain. My bad, guys. Codomain. Whenever the range is equal to codomain, it's onto, and whenever the range is not equal to codomain, it's into. Perfect? Fine. I am drawing few arrow diagrams, and looking at them you will be able to understand what are the 4 types of functions. 2 types you already saw, onto and into. 2 type you already saw, guys, onto and into. Onto and into. Repeat, what is onto function? Onto function means when the range is equal to codomain. I am drawing a diagram like this. Can you see? Each input has a different output. So it is 1 to 1 onto. It is 1 to 1 onto. I am drawing a diagram like this. Can you see? Different inputs have same output. 2 arrows coming and hitting a same target. It is many to 1 into. It is many to 1 into. Many to 1. Many to 1. Here it's 1, 1, 1. Everything different. 1 to 1. Next one. But only difference is here we have extra elements in codomain, because range and codomain don't match. Here the number of images is same as number of elements in set B. The number of images is same as number of elements in set B. Here we have extra elements because its codomain is bigger than the range. Range is always a subset of codomain. Range will always be a subset of codomain. Do you agree? Range is nothing but a part of codomain. From the codomain you select few and get range. Next, here. This is many to 1. Can you see? Many to 1. But why is it onto? Because range and codomain are equal. The number of output is equal to number of elements in set B. Here. One to 1 into. Can you see it's 1 to 1 into? Each element has a different output, but there are extra elements. That means the range is not equal to codomain. The range is 3 elements, codomain has 5 elements. That's why range codomain not equal, it's onto. Why it's 1 to 1? Each input has only different one output. Unique outputs you have. Here the outputs are not unique, many to 1. Outputs are unique, 1 to 1. Outputs are not unique, many to 1. These are the 4 types of functions. 1 to 1, onto, many to 1, in 1 to 1, many to 1, onto, into. 1 to 1, many to 1, onto and into. 1 to 1 is also called as injective, and onto is also called as surjective. When you combine 1 to 1 and onto, you get injective plus surjective, which is equal to bijective. What is a bijective function? Which is both injective and surjective. That means which is both 1 to 1 and onto. The first function is called as bijective function. So people who understood this, kudos to you. Those who couldn't understand, nothing to worry. There is a lot of scope to study in class 12th. You can just skip this part if at all you didn't understand. For people who are focusing for long term, they must have revised this very well for now. Are you clear? Perfect. Some standard functions, we will go through some of the standard functions, their graphs, domains, very quick, guys, because yes, it's a revision session and I at times tend to forget that I need to revise and not teach. Identity function is when the input output is same. The graph of an identity function is a line passing through origin. Suppose this is x and y. This is the graph of line y equal to x. Identical. Input output same. Identical. The domain is all real numbers. The range is all real numbers. It will be better if you guys make a chart out of it. Next. Modulus function, Guys, I would also take a minute to talk about the function y equal to x square and y equal to x cube, which come under the segment of polynomial function. I have not taken extra slides for that, but yeah, it's time to talk about it. Y equal to x square is a graph like this, a smiley, isn't it? Do not draw these eyes. This is y-axis, x-axis. It's a parabolic curve. Domain, all real numbers. But what about the range? It's always 0 to infinity. Can you see? On y-axis, it's always positive. In fact, non-negative, never negative. The square function, the work of square function is to square the input. That means square and give only positive numbers. X cube, y equal to x cube graph is like this. Sorry. This is the graph of y equal to x cube. Domain all real number and range also all real number. We know in cubic function 2 cube is 8, minus 2 cube is minus 8. So output can be both positive, negative, everything. Modulus function is one of the crucial functions. Mod means split. Guys, whenever you have mod, you will split into two parts, plus x, minus x. Plus x when x is greater than equal to 0. Minus x when x is less than 0. Equal to sign can be placed anywhere, up or down. It's fine. Now, why we chose the point 0? Because 0 is the vertex for this graph. For this graph, the vertex is 0. That means this graph has its point, sharp point at 0. Modulus graph will always be V for Varshama, V for Varshama. Its task is, it gives out absolute values. It will always give you absolute value as return. That means inside a mod machine, two vertical lines, if you put 3, it will give you 3 as output. If you put minus 1, it will make it positive and give. How sweet of modulus. It removes the negativity for you. It will remove all the negativity. If you given minus 3 by 9, it will give you plus 3 by 9. How sweet of modulus function. V for Varshama, V for mod function. Right. So I remove negativity around me and same modulus copies me. Right. Okay, great. So absolute value is what we get. The vertex is 0. How do we get vertex? Anything inside the mod, you put it equal to 0. When you put anything inside the mod, you will get the vertex. Suppose y is equal to mod of x plus 5. What will be the vertex? Put x plus 5 equal to 0. Minus 5 will be the vertex. Minus 5 will be the vertex. So that means once taking positive sign when x is greater than equal to minus 5 and taking a negative sign, overall negative, when x is less than minus 5. So this minus 5, how do we get? I hope you have understood. While drawing the graph of this, it's a V-shaped graph. Vertex is minus 5. So at minus 5, 0, you will get a V curve. That's it. Modulus function has some property, couple of properties. I'll quickly note down. The first property, where to write? The first property is root of x square is equal to mod x. Very, very important. Used at a lot of places in trigonometry, inverse trigonometry. Next year, you will be using is, guys, write it down. Couple of more, like mod of x plus y will be greater than equal to mod x minus mod y and less than equal to mod x plus mod y, the whole in mod, of course. Similarly, if you have a minus sign here, the formula is still the same. The formula will still remain the same. If you have mod x into y, it can be separated as mod x into mod y. If you have mod of x upon y, it can be separated as mod x upon mod y. These four properties, 1, 2, 3, 4, 5. Here there are 2, plus and minus both. Signum function, signum. This signum function says it will have only 3 outputs, 1, 0, minus 1. When will the output be 1? When input is positive. When is the output 0? When input is 0. When is the output negative? When input is negative. From here onwards, guys, we are starting piecewise functions. Before this, all the graphs were drawn with a single stroke. right? I didn't have to lift my pen in order to draw the graph. They were continuous functions drawn with a single stroke. Now the functions, now the graphs will be piecewise, that is broken. That was I will have to lift my pen. These are called piecewise functions, signum, GIF, fractional part, right? This is a graph, all the positive numbers 1, all the negative numbers -1, at 0 it is 0. This is the graph. I had to lift my pen, you could see it. Domain, all real numbers. Range. What is the range? Range is 3 fixed values, 1, -1, 0 and +1. In the previous one, did I write the domain and range? Domain, all real numbers. Range, you can see it will remove the negativity out of the line. That is 0 to infinity. For modulus, 0 to infinity. For signum, only 3 particular outputs, you can see why. GIF, very important function, also called as step function or floor function. Why it is called as step function or floor function? Step function because of the disco divane, the graph nature. It's like steps written in bracket like this. It gives the left integer as output. I will not write the definition in your textbook. This is the simple way to understand. It will always give the left integer as output. Suppose the input is -3.2, the output will be on a number line. What is the integer on the left of -3.2? It's -4. If the input is 4.1, the output will be, what is the integer on the left of 4.1? It's 4. So it will always give the left integer as output. The graph is like this. Okay. Something of this sort. Can you see steps? Right. I have to break my, there are breaks in between. It's also a piecewise function. Domain. What is the domain of this graph? Domain, all real numbers. Input can be anything, guys, but range is always integer. It is giving me integer as output. Positive, negative depends, but it will give me integers only. Another property of this is whenever you have GIF value to be equal to t, this will imply, suppose GIF of x is a particular value t, where will x lie? X will be greater than equal to t and less than t plus 1. Suppose GIF value is an, what is t? T is an integer. T is the output. So x will be lying between t and t plus 1. X will be lying between t and t plus 1. Fractional part function. The fractional part function is written like this in curly brackets. We know any number is composed of two parts. It's integral part and fractional part. So from here, by rearranging, we'll get fractional part to be equal to number minus GIF, number minus integral part. As the name suggests, guys, it will give fractional outputs. The output will be in fraction. Fraction means between 0 to 1. 0 included? Yes, between 0 to 1. Domain nahi, domain is all real number, range is 0 to 1. 0 included, 1 excluded. You take any number. Take x as 32. What will be its fractional part? 32 minus GIF of 32, 0. Take x as 4. What will be its fractional part? 0. Take x as minus 11. What will be its fractional part? Minus 11 minus of minus, right, the number, okay, minus 11 minus GIF of minus 11 is how much? Minus 11 minus GIF of minus 11 is minus 11, 0. Can you see for integers the fractional part is always 0? That means I can note down a property: when x is an integer, fractional part will always be 0. But when x is not an integer, like 3.2, what will be the fractional value? You will substitute 3.2 minus 3.2. When x is minus 2.8, what will be its fractional value? Minus 2.8 minus plus 3, which is again 0.2. Can you see the output will always be between 0 and 1? We are never getting equal to 1. So that's why 1 is not included. This is how it looks. Between 0 and 1. Again, I have to break. It's a piecewise function. These upper limits are 1 and this is 0. Input can be anything. Output is 0 to 1, 0 included, 1 excluded. Exponential function, guys, y is equal to a raised to x. Just know the graph. First one, a is greater than 0. Second one, a is greater than 0 but less than 1. Know about the domain and range. That's it. Domain and range. When a is greater than 0, the exponential function is this, increasing. When a is between 0 and 1, the exponential function is decreasing. The domain, can you see x-axis has everything, all real numbers? It is now continuous, it is not a piecewise function. But range. Yes, range is always 0 to infinity. 0 is included? No. It is not touching 0 at all. 0 is not possible. For logarithmic, just reverse these values. For logarithmic, y is equal to log x to the base a. Y is equal to log x to the base a. Here the condition for logarithm is x should be greater than 0. A is greater than 0. A is not equal to 1. Here let us say a is greater than 0 and less than 1. Of course, not equal to 1. The graphs will be different for both the types. Domain, range. The domain for this type of a graph will be this way, 1, 0. And the graph for the other part will be this way, 1, 0. In the previous one also, there is point 0, 1, 0, 1. Guys, here domain can be only 0 to infinity. Can you see? I cannot take x as 0. It is always greater than 0. So 0 to infinity. What about the range? Range is plus y minus y. Range is all real numbers. So basically in exponential you had the reverse of this. In logarithm, again a reverse. Okay. Last few part, guys. Last few portion left. Then couple of questions. Properties of logarithm. Properties of logarithm. The exponential law says log of a raised to b can be written as b times log a. First one. Second, log of a, let me use x and y. Log of x to the power y is equal to y times log x. Base is something. Log of x into y will be equal to what? If base is this, it is log x to the base a plus log y to the base a. The product rule. Two things multiplied will get added. If the two numbers are getting divided, guys, remember the base should be same. If two numbers are divided, we subtract them. Quotient rule. Exponential product quotient. Fourth one. Log x to the base y can be written as log x to the base a upon log y to the base a. Change of base law. We are changing the base. Instead of y, we brought a new base by separating them. Log of a to the base a is always 1. Any number to the same base is always going to give you 1. Log 1 will always be 0. You put any base here. Not 1, because base by definition cannot be 1. You put any other base, you will get the answer as 0. 7. A raised to log b to the base a. If these two numbers are same, like a and a, then the answer can be directly written as B. This B will directly come here. And the last property, a raised to log B, no, let me change it. Yeah, a raised to log B to the base C can be written as same now. Yeah. A and B interchanged, B raised to log A to the base C, just A and B interchanged. These are the 8 properties of logarithm which we need to know for solving questions, log being an important part. When the base is E, natural log. When the base is 10, common log. E is Euler's number, E is a constant. Last part guys, algebra. The algebra of functions, addition, subtraction, multiplication, division, reciprocal. First one, addition. Let us consider in general. I am considering in general a function f of x and a function g of x. We are going to deal with f of x and g of x. A function f of x from d1 to y and a function g of x from d2 to y. What is d1? Domain, d2 domain of g. Y are nothing but codomain, not range. People, very important, if at all you have missed or I have missed while studying function, the first thing is whenever writing a function from x to y, this is how you represent a function. The x is the domain and y is codomain. This is how a function is written. A function f mapping from x to y. A function f mapping from x to y. That means inputs are from x, outputs are from y. Two functions are given. If we are adding the two functions, how do we add? It's simple addition guys, like you do any two numbers, the way you add any two numbers, same way you add two functions. The only difference is on addition, their domains will be intersected. It will become d1 intersection d2. The domains will get intersected, codomain is same. Similarly, when you subtract, again the domains will get intersected. Right? What happens when you multiply and divide? Same thing. F of x into g of x, directly you can multiply, and f of x upon g of x, directly you can divide. Only when you are dividing, please remember that g of x should not be 0. Make sure that denominator is not 0, isn't it a obvious thing? And also reciprocal, when you are taking reciprocal, that means 1 upon f of x. There is a function f, you are just reciprocating it. Make sure f of x is not 0. Okay, fine. And last one, scalar multiplication. In physics you have studied scalar means constant. So whenever a function f is multiplied with a constant x, nothing, you just multiply it with, suppose f of x is 3x square plus 2. Now you want minus 2 times f of x. It is minus 6x square minus 4. What happens to the domain and range? Nothing. Because I am multiplying with a constant number, the domain and range remains unaffected. I mean the domain for f of x was d1, it will remain same, range will remain same. In reciprocal, what will be the domain? Because we cannot put, domain will be d1 minus f of x equal to 0, because f of x can't be 0. So from the domain, you remove the denominator 0 part and it is mapping to y. Similarly for division, it is d1 intersection d2. The domain is intersection, but because g of x can't be 0, make sure g of x equal to 0 is removed to y. And once again d1 intersection d2 to y. Got it? For scalar multiplication, no change. This is the algebra of functions. That means everything that you have to do with functions mathematically. It was quite a big chapter, so I took a good enough time to finish only the theoretical part. Last but not the least, two things, just FYI. There is something called as even function and odd function. Even function is when f of minus x is same as f of x. And odd function means when f of minus x is equal to minus f of x. If you need an example, try with the function, take f of x as x square. Instead of x, take minus x the whole square is same as x square. So even if you replace x with minus, there is no change happening, it's an even function. On the other hand, if you take f of x to be equal to x cube, replace x with minus x the whole cube is minus x cube. That means you're getting minus sign outside. It is a odd function. With this, the theory part of this chapter is done from my side. I will go to few questions and then end it. X is a natural number, x is an even natural number, then what is the intersection of two? Consider the set of all natural numbers. Sets, it's actually a question of sets chapter. All natural numbers, within that we have even natural numbers. Obviously, intersection is the smaller one, that is set B. Why a question of set appeared here? Two functions are said to be equal if. Now note this. This was a part of theory. I knew I couldn't write this much, so I thought let's take it as a question. Two functions are equal if the domains are equal, codomains are equal, and the functions are equal. That means all of the above is the answer. All of the above is the answer. Range should not be equal. Domain, codomain, and function should be equal. Next, what is domain for this function? Let's calculate the domain. We just learned about log function. Firstly, for calculating domain, there were four types: linear, denominator, root, and combined root and denominator. Which type? Third type. In third type, ma'am said whatever is inside the root should be taken as greater than equal to 0. That's what ma'am taught us. Fine. When is log value greater than or equal to 0? From the graph of log. Base is 12. There were two graphs for logarithms. Base is 12. Which graph will we go for? The first one. When is the value of log greater than or equal to 0? This point is 1, 0. This is 0, 0. Can you see? When is the log value greater than equal to 0? When is y greater than equal to 0? When I am taking x greater than equal to 1. When I am taking x between 0 and 1, I am getting negative value. Between 0 and 1, y is negative. Above 1, y is positive. So in order to justify this, log value is greater than equal to 0, I will mean that x square should be greater than or equal to 1. If x square is greater than or equal to 1, by inequality, x should be greater than, mod of x should be greater than equal to 1. Right? That means all the values greater than 1 and less than minus 1 are allowed. Nothing between minus 1 and plus 1. If you want to solve it by wavy curve, x square minus 1 greater than equal to 0. X minus 1, x plus 1 greater than equal to 0. On a number line, minus 1 plus 1. Plus, minus, plus. We need greater than, that means this and this. These regions is what we want. Still, if you get this, you won't be able to mark the answer unless you know that answer is away from 1, more than 1 always, either positive or negative, but 1. Modulus, if you neglect the sign, it is always more than 1 here, more than 1 there, neglecting the sign. That means mod of x is always greater than or equal to 1 will be the answer. Perfect. The domain of this function is how much? From trigonometric functions, we know cos of 3x. Okay, we can answer it directly. Cos of 3x always lies between minus 1 and 1. So minus cos of 3x will always lie between minus 1 and 1. Adding 2 on both the sides. Minus 1 plus 2. Minus 1 plus 2 is 1 and 3. 1 by 3. Next, last step, reciprocal. 1 upon 2 minus cos 3x. Take the reciprocal. It's 1 by 3 and 1 of course, because when you take reciprocal, the inequality reverses. 1 by 3 to 1. 1 by 3 to 1. Where is it? I feel this is a trap. The answer should be all real numbers, right? Yeah, we need the domain, guys. Go to the types. See, even I can make mistake. Go to the chart. Linear, 1 by denominator, root and mixed. Isn't it 1 by denominator? That is 2 minus cos 3x should be not be equal to 0. Right? In denominator type, what do we consider? Denominator should not be 0 and then we try solving it. When you solve this, cos 3x should not be equal to 2. Is it possible ever to get a value of cos 3x as 2? No. Cos will always be between minus 1 and plus 1. It can never be equal to 2. That means what can I take the value of x? X can be any number. X can be any real number. Because whatever number you will take, it will never be equal to 2. There is no condition on x. X can be anything. The answer is all real numbers, people. The answer is all real numbers. Understood? Next, what is the domain for this relation? Now, this is the relation between x and y. You have to find the relation set and then the first elements. If I try to write the relation set, what are the numbers which when substituted here will give me the answer as 16? 4 0 0 4 minus 4 0 and 0 comma minus 4. Please keep in mind what is x and y. Integers to real numbers. The relation is from integers to real numbers, z to r. That means input can be positive number as well as negative number. That's why I have taken the inputs as positive, negative both. If instead of z this would have been natural number, I wouldn't have taken the negative one, only positive one. Right now it's fine. 0, 4 and minus 4, that is option B, comes out to be the correct answer in this case. A differs from B by 3, which is the correct answer? I just took this, it's a very easy question, but the reason for taking it was to see how many of you all can tell me the right answer. A differs by 3, 1 minus 4 minus 3. So A differs by 3, that means A minus B should be 3, not B minus A. 4 minus 1, we are not talking difference should be 3. From first minus second should be 3. B is the answer. No confusions. Further, what is domain of this function? Interesting. One thing we know for a log function. For a log function, its domain should be greater than 0. Log x to the base a, x should be greater than 0. Here instead of x, we have x minus gif of x should be greater than 0. Right? X minus gif of x is nothing but fractional part should be greater than 0. Now try to recall what should be the value of x. The question is now, in order to get fractional part greater than 0, what should be x? Try to recall the slide where I said fractional part is 0. Fractional part is 0 only at integers. Fractional part is 0 only at integers. At integers, fractional part is 0. That means when it is not an integer, it's fine. Fractional part will be 0 when x is integer. I don't want 0. That means x should not be an integer. X should not be an integer. Right? Answer is all real numbers minus integer. Interesting. If you are able to understand this, you are going to love mathematics. This is how fun it is. If I wouldn't have been under the pressure of 1 hour complete chapter revision, I would have gone on and on and on for non-stop at least 3 to 4 hours teaching this chapter. It is love. Okay, total number of non-empty relations, I guess I made a note out of it. M and N are number. So total number of relations 2 raised to Mn. When you subtract 1 out of it, you will get non-empty relations. Very important. If this is a quadratic equation where this denotes greatest integer function, solve and find the value of x. That means get the domain. It's a quadratic equation. For people who get confused, you can substitute this GIF of x to be equal to t and make it a nice sweet quadratic function which can be factorized as 2 3s are 6. That means t is equal to 2 or t is equal to 3. T is nothing but GIF of x is equal to 2 or GIF of x is equal to 3. Now how many of you all recall? How many of you all can recall the GIF function? A property that I noted for you. I will show you. If GIF of x is t, that means x is between t and t plus 1. The question that we are solving, GIF of x is equal to 2. That means x will be between 2 and 3. X will be between 2 and 3. Note, here there is equal to, here there is no equal to sign. Equal to and no equal to. Everybody ready to apply? Good. Here we go. If GIF of x is 2, that means x is greater than equal to 2 and strictly less than 3. Same number and one additional. Or x is greater than equal to 3 and strictly less than 4. Or means union. So 2 to 3 and then 3 to 4. There is a 2, 3, 2, 3, 4. It is saying 2 to 3 and then 3 to 4. 4 is not included. 2 is included, 4 is not included. So 2 to 4, 2 closed interval, 4 open interval. 2 closed interval, 4 open interval. Answer is option D. F of x is ax plus b real valued function. F of minus 1 is minus 5, f of 3 is minus 3. Find the value of a and b. F of minus 1 is minus 5 means when the input is minus 1, output is minus 5. Input is 3, output is minus 3. F of minus 1 is equal to minus a plus b. What is f of minus 1? Minus 5 is equal to minus a plus b. Similarly, when I put x as 3, f of 3 minus 3 is equal to 3a plus b. Subtract the two equations, changing the signs. B cancels. Minus 5 plus 3 minus 2. Minus a minus 3a minus 4a. A is equal to 1 by 2. A is 1 by 2, only one option is there. So I can go with B. Able to understand. Lovely. Great. You can find B if you want. But yeah, minus 9 by 2. For this function, what is domain and range? Which type? Domain, 4 types. Linear, denominator, root and mixed. It is denominator. And whenever we have a denominator, we say that denominator should not be 0, x should not be 4. That means domain is all real numbers minus 4. Any option with all real numbers minus 4? There is only one option. Still, we will check the range. Still, we will go for the range. Guys, can you see this f of x? If I take a minus sign common from the numerator or denominator, wherever you prefer. If I take a minus sign common from numerator, these two will get cancelled and f of x is equal to minus 1. What is f of x? F of x is nothing but y. And what is y? Y is range. So range is a single element minus 1. Range is equal to minus 1. That's how we find a domain range for this question. Got it? I think that's a lot of practice, lot of questions. Hope all the hard work will be paid off. You guys will be watching the sessions thoroughly, sharing with your friends, because here you are getting quality education, that too full free, right? Me, Varsha, signing off and going to prepare for the next lecture for you guys. Till then, you prepare for this session and let me know if you have any doubts in the comments. I will respond to all the doubts in the comments as well. Thank you so much. Keep smiling, guys. You have a long way to go. You are just in 11th class. Do not get scared of all this. If at all you are getting scared, let me know that too. I will tweak the level based on my audience, based on my students. Thank you so much. Bye-bye. Have fun.